The Voyager 1 space probe was launched in September 1977. In February 1990, Voyager 1, after completing its primary mission of studying Jupiter and Saturn, began its journey into interstellar space. It was then that mission controllers decided to turn the probe's camera inward toward the solar system and take pictures of several planets. The photo of Earth, taken from 6 billion kilometers away, became known as Pale Blue Dot and served as inspiration for the book of the same name by astronomer Carl Sagan. Sagan, in fact, was one of the scientists who suggested that Voyager 1 take pictures of the planets from so far away. At that distance, a signal containing commands sent to the probe would take more than 5 hours to reach Voyager 1, and another 5 hours for mission controllers to receive a response. The signal travels at the speed of light. Today, in 2024, after 47 years of traveling into interstellar space, Voyager 1 is about 24.7 billion kilometers from Earth. That's about 0.0026 light years. Surprisingly, controllers are still in contact with the probe. To communicate with it at that distance, it takes 22 hours and 50 minutes for the signal to reach the probe, and another 22 hours and 50 minutes for it to return a response. Voyager 1 is the most distant man-made object from Earth, and in 47 years of travel, it is not even close to 1 light year away from us. Its speed is just over 60,000 kilometers per hour. Light from Proxima Centauri, the closest star to our solar system, takes 4.2 years to reach us. The speed of light in a vacuum is just under 300,000 kilometers per second. Light from the Sun takes 8.3 minutes to reach Earth. In addition to light, every massless particle and every field disturbance travels at the speed of light. It takes more than 87,000 years for light to travel from one side of the Milky Way, our galaxy, to the other. The speed of light is also the speed of information. This means that if we could observe a planet 87,000 light years away from us, we would be seeing what was happening there 87,000 years ago. And vice versa. Let's say an alien civilization lives on a planet 87,000 light years away from Earth. Let's speculate that they have fantastic technology that allows them to observe all the light emitted and reflected from our planet in minute detail. They would see a few members of our species, Homo sapiens, living with the Neanderthals. They would see mammoths, but they wouldn't see any of us on the continent that we would come to call America, since humans only began arriving in the Americas about 20,000 years ago. The closest galaxy to the Milky Way is Andromeda. It is about 2.5 million light years from Earth. The light from the Milky Way that is reaching it now is the light from a Milky Way whose Earth did not even contain Homo sapiens, who only appears in the fossil record 300,000 years ago. Between 2.5 and 2 million years ago, Homo habilis, our first ancestor of the genus Homo, derived from the Australopithecines, appeared. Andromeda, however, is hurtling towards the Milky Way at a speed currently estimated at between 100 and 140 kilometers per second. At this speed, the two galaxies will begin to collide in 4.3 billion years and will merge in 6 billion years. However, the distances between the stars are so vast that when this collision between the galaxies occurs, there will be virtually no collisions between individual stars, given the enormous space between all the stars in each galaxy. The universe is expanding, and barring some unprecedented cosmic scale change, it will probably continue to expand forever, eventually resulting in maximum entropy, an event physicists call heat death. This will only occur on an incredibly long timescale, well beyond trillions of years in the future. Currently, measured by the Big Bang event, the universe is about 13 or 14 billion years old. We live in a young universe where stars are still forming all the time. Many solar systems and potential Earths could emerge. But being alive in the early days of the universe doesn't mean we have it all at our fingertips. Remember, the speed of light in a vacuum is the speed of information. Gravitational waves travel at the speed of light. If the sun disappeared in the blink of an eye, the Earth would only go dark and stop rotating around it 8.3 minutes later. And remember, the universe is constantly expanding. More than 90% of the universe that we can see with our telescopes is beyond our reach, even if we traveled at the speed of light, which is impossible since nothing with mass can reach that speed, because that would require infinite energy. Most galaxies are moving away from us faster than the speed of light, because what is increasing is the space between them, which is not subjected to the speed limit. In 2 trillion years, the light from most galaxies will no longer even reach us. If there are astronomers by then, they will think that nothing exists beyond the local group of galaxies in which they live. But we don't need to worry about any of that, since our sun will have died long before that time, about 5 billion years from now, to be precise. The Earth will have died long before the sun, because it will expand, frying our planet and perhaps swallowing it. Even if the sun does not swallow us, its gradual expansion will make it so bright and so close that life will be impossible. Even if we were to advance technologically to the point where we could escape from here and reach the stars, the journey would still be too long and absurdly expansive. Furthermore, almost all of the exoplanets discovered so far are extremely hostile to life, just like the other planets in our solar system. As much as one might imagine otherwise, the truth is that, barring some miracle, we're here to stay. Long before any cosmic catastrophe, humanity will be extinct in the same way as most other species that have ever existed. Or we will become other species through evolutionary processes. We may even become dumber, as there is no guarantee that intelligence will continue to be an evolutionary advantage. Meanwhile, Voyager 1 will almost certainly be hurtling through space, because the chance of it colliding with anything is ridiculously small. It's strange to think that there are places in the universe right now where the light from our sun has traveled 100 million years to reach. In other words, the light that lit up the dinosaurs is only now reaching planets 100 million light years away. In other places, the light from when our solar system was still forming billions of years ago has not yet arrived. This is the vastness of space, the vastness of the universe. It is in this vastness that we believe we reign. It is in this vastness that we imagine ourselves to be special because we have feelings produced by chemical compounds shaped by countless generations. Generations that were selected by nature to survive and perpetuate the species.